Welcome back to DM Academy. Okay, let's have this topic: position vector, velocity vector, and acceleration vector. Okay, for first problem, a particle moves along xy plane with coordinates as a function of time given x is equal to 1.60 meter per second square t square and y coordinate is equal to 3.20 meter per second cube t cube minus 4.00 meter per second t. Okay, so for this problem, our aim is to find letter A, determine the position vector as a function of time. For letter B, we will determine the velocity vector as a function of time. And for letter C, we will determine the acceleration vector as a function of time. Okay, take note that for letter A, since we're looking for the position vector as a function of time, the position vector is denoted by R, wherein the position vector is just the sum of the position vector along x and along y. And for the velocity vector, to find this, all you have to do is to find the derivative of the position vector. And lastly, for the acceleration vector, we will find the derivative of the velocity vector. Okay, so let us solve it one by one. For letter A, determine the position vector as a function of time. Okay, take note again that the position vector is denoted by r of t, and that is equal to the position vector along x, I hat, plus the position vector along y, j hat. Okay, so position vector r of t is equal to, so given the x coordinate of 1.60 meter per second square t square, this is along I hat, plus for y 3.20 meter per second cube t cube minus 4.00 meter per second t, and these two are both along j hat. Okay, again, this position vector r of t is equal to 1.60 meter per second square t square, I hat, plus the quantity of 3.20 meter per second cube t cube minus 4.00 meter per second t j hat. Okay, this is the position vector as a function of time. Okay, then for letter B, we will determine the velocity vector as a function of time. To determine the velocity as a function of time, the v of t is again the derivative of the position vector with respect to time. Okay, so let's have this one. V of t is equal to the d over dt of the r of t, which is the position vector, 1.60 meter per second square t square, I hat, plus 3.20 meter per second cube t cube minus 4 meter per second t j hat. Okay, the v of t, or the velocity vector, is equal to the derivative of 1.60 meter per second square t square is 3.20 meter per second square t, I hat, plus the derivative of 3.20 meter per second cube t cube is 9.60 meter per second cube t square minus derivative of 4 meter per second t is 4 meter per second j hat. Okay, so this one, again, the velocity vector is 3.20 meter per second square t I hat plus the quantity of 9.60 meter per second cube t square minus 4 meter per second j hat. And lastly, the acceleration vector. Let us determine the acceleration vector denoted by a of t, and that is the derivative of the velocity vector with respect to time. Okay, so we have the a of t is equal to the d over dt of the acceleration, or rather the velocity, that is 3.20 meter per second square t I hat plus the quantity of 9.60 meter per second cube t square minus 4 meter per second j hat. Okay, so the acceleration vector is equal to the derivative of 3.20 meter per second square t is 3.20 meter per second square I hat plus the derivative of 9.60 meter per second cube t square is 19.2 meter per second cube t, and the derivative of 4 meter per second is 0. So this is 19.2 meter per second cube j hat. Okay, so again, this is our acceleration vector, 3.20 meter per second square I hat plus 19.2 meter per second cube t j hat. Okay, that's it. Let's have another problem. Okay, for the next problem, a particle moves along xy plane with a position vector given r of t is equal to 4.60 meter per second square t square I hat minus 3.20 meter per second t j hat plus 5.00 meter k hat. Let us determine the position vector when t is equal to 5 seconds. Okay, so given the r of t, or the position vector as a function of time, 4.60 meter per second square t square I hat minus 3.20 meter per second t j hat plus 5 meter k hat. So to find the position vector when t is equal to 5 seconds, let us just evaluate this r of t by substituting time be equal to 5 seconds. So we have r of 5 seconds is equal to 4.60 meter per second square, 5 second square I hat minus 3.20 meter per second times 5 seconds j hat plus 5 meters k hat. Okay, so we have 4 meter per second square. Square of 5 is 25 I hat. Okay, minus 3.20 20 times multiplied by 5 give you 16. 16 meters as we cancel out the unit seconds. Then j hat. Then plus 5 meters k hat. Okay, then the position vector when time is 5 seconds is equal to, I'm sorry, this must be, the 4.00 must be 4.60. Okay, this must be 4.60. Okay, then 4.60 multiplied by 25 is 115. Then we will cancel out the second square unit. So 115 meter I hat minus 16 meters j hat plus 5 meters k hat. Okay, that's it. The position vector is, when t is 5 seconds, is 115 meters I hat minus 16 meters j hat plus 5.00 meter k hat. Thank you for watching.